Okay, here we go. We're going to do elimination part 2. Get to the harder problems that are on Delta Math. Just making sure that we're going. We are. Okay, so what we want to do here is very similar to what we were doing last class, except for we notice something right away, right? When we look at this, we're like, wait a minute. Nothing cancels out, right? If we went ahead and added these together, nothing cancels out. And so this is where I do something that's called like, just make a wish. Okay, not make a wish like I want to go to Disney World, but make a wish like, oh, you know what? If only this one were negative 8x, then I could add it and it could go away, right? Like the x's would go away. So, but in math, we can make a wish and we can actually make it come true. So what I'm going to do is I'm going to take this equation, I'm going to work with it. Let's bring it up here and rewrite it and say, you know what? We are going to make this term a negative 8x. And we're going to do that by multiplying it by 2. So what we're going to do, and this is legal, we're allowed to, let's take a multiplying, bright green. If I multiply this term by 2, I get negative 8x, right? But if I'm in an equation and I multiply one of the terms by 2, I just messed up the equation. But if I multiply every term by 2, the equation still stays the same. It's kind of like this, like if you're cooking, I'm going back to the cooking again, and you've got a balance on your kitchen countertop, and you have, 3 cookies on one side and 3 cookies on the other side. Okay, they're equal, right? Well, if you go ahead and double the amount of cookies on the right side, if you're like all of a sudden like 3 cookies times 2, well, that's 6 cookies. Well, they're not going to be equal anymore, right? But if you double the other side, then they will go back to being equal. So that's what we're doing here. We're doubling this term. We're also going to double that term. So negative 2y times 2 is negative 4y. And wait, that's not all. We have to double this term. So I don't know why the negative kind of went away. So negative 26 times 2 is going to be what? The 12, the 52, right? Negative 52. All right. And so now we're like, hey, we made a wish, we made it come true. And now you know what we can do? We can just take this equation and bring it right under, because guess what? They are now, we can add, and they're now going to cancel out the x's, right, when we add. So let's go ahead, let's bring in our rust. I think we have this rust. All right, so now let's go ahead and add them. Negative 8x plus 8x, gone. Negative 4y plus negative 10y is negative 14y. And this is going to, I'm picking up my calculator. This is my 3rd video I've made, and I don't trust my ability to do basic math. Negative 52 plus 38. Sometimes you just have too much talking, too much mathing. Okay. Ooh, this is nice. We're going to divide both sides by negative 14, and we get y equals 1. Once again, we are very clever, and we make sure that when we solve for y, we put it in the correct spot. That is the new lesson. That's the new part of the lesson. The rest of it's old. So let's just get a different color, and let's just do the old part. Now that we've solved for y and we know it equals 1, now we're going to go to, I don't know, this one looks easier, right? There's less negatives. We're going to rewrite this, but when we see the y, we're going to take it, throw it away, and in comes the 1. So that's old news, right? We've been doing this over and over. We're going to rewrite the 8x. Negative 10 times 1 is negative 10. Then we're going to go, we have a 2-step. Let's add the 10. 8x equals 48. Divide both sides by 8. X equals 6. Okay, so that is our x, and we're done. So once again, we're using algebra instead of graphing, but if we did graph these 2 lines, they would intersect at the point 6, 1. All right, so that's really our new thing, is we are making a wish and making it come true. Now, that was level 1. So level 2 actually, or no, is this level 2? Level 2, we're still level 2. But here, see how this one, we mess with the first terms? This one, we're going to mess with these terms, okay? So I can't make a 6 into a -9. I can't make a 9 into a -6. So we're like, we're going to ignore those. But this 2y, if I could just make that into a -6y, then the y's would cancel out and I'm good to go. So what do I have to multiply 2y by to make that happen? A -3, right? So we're going to do the same thing we just did. We're going to, let's keep with the same thing. We're going to go ahead and rewrite this, the 9x plus 2y equals 16. And we're like, you know what? I am going to multiply each term because I want him, the 2y, to be a -6y. I'm going to multiply by this one by -3, multiply this one by -3, multiply this one by -3. Is that confusing? Does that look like x minus 3, x minus 3? Sorry. All right, so here we go. We're multiplying. And so we've got 9 times -3, that's -27. And then, of course, 2 times -3 is 6y. And 16 times -3 is -48. And so, yay, we're like, we're good to go. Now we're going to go ahead and take the one we didn't mess with, this one, and we're going to bring it and put it right underneath the one where we made the wish and then we made it come true, right? We wished it was a -6 and bam, it became a -6. So let's go ahead and add. Did I continue to do black? I guess we can do that. All right, so we're going to -27 plus 6, that's -21x. The -6 and 6y gone, bring down the equal. -48 divided by 6 is -42. This looks good, right? Just divided by -21. And we get that x is 2. So we're going to go down to the x spot, and we're going to put a 2. And we know what to do next, right? We're going to take our purple. We are going to take either one we can take. I'm going to take the 6x plus 6y. We could do either one, right? And when I see x, I'm going to rewrite the 6. When I see x, I'm taking it and throwing it away. And I'm plugging in the 2. Here comes the 2 with its parachute, landing on both sides. And then I'm going to solve for y. 6 times 2 is 12. Now I got a 2-step. Subtract the 12. That's 6y equals -6. Divide by 6. And get y equals -1. And we're going to put that y here. Once again, if we graph these two equations, they would intersect at the point 2, -1. All right, let's keep going. So same thing here, except for, let's see, did I skip anything? Nope. All right, we did that one, that one. Okay, same thing here, except for now we have some new options, right? So far we've been doing the things that just have one solution, like, 2, -5, that's one solution, okay? But here we have some options. Sometimes we'll have infinitely many solutions, and other times we will have no solutions. So let's see what that's going to look like. All right, let's get rid of that. All right, so once again, we're going to make a wish, and I'm going to focus on these two. I could have focused on these two. Either way, right? It doesn't really matter. We'll get the same answer. Let's focus on these two because if this guy were a -2y, wouldn't everything work out? So I'm going to work on that one first. Once again, you could have picked a different one, and that's the beauty of math. It doesn't matter if you use a correct method. There's options, right? Options come up with the answers. All right, so to make him a -2y, I have to multiply everybody by -2. This time I'll just put parentheses because we know parentheses mean multiplication. So -5x times -2, that is a positive 10x, right? Then that's a -2y, and that's a positive 6. Now we're going to go ahead and let me see if I can get rid of this stuff because I can barely see my numbers. All right, so now we're going to say, all right, now it's time to bring this one underneath and see what happens. And we immediately go, wait a minute. Do you all see it? Do you see what's going to happen here? When we add 10x minus 10x, that's gone. -2y plus 2y, that's gone. When everything's gone, what's left? Nothing. And the number for nothing is 0. Oh my gosh, look what happens on this side. 6 minus 6, 0. Gone. All right, now, when our x's go away and our y's go away, we have to look at what's left. This is a statement. It says 0 equals 0. Is that statement true? It is true. And what that means is that it doesn't matter what your x's or y's are because they cancel out anyways. So no matter what your x's and y's are, they are going to cancel out, and we have infinitely many solutions. Okay, that's what I'm saying. Infinitely many solutions. And if we graphed these two lines, they would be just right on top of each other. Okay? They're the same line. They're the same line. And you might be able to see it if we took this and divided every term by 2. Wouldn't we get that? We sure would. So sometimes on Delta Math, you're going to be seeing these and the x's and y's fall away. You got to look at the statement. If it's a true statement, that means that no matter what x and y's you pick, these two are the same lines. They're going to work. Infinitely many solutions. All right. Let's keep going. I think I have 2 more, so let's see the other options. So here, oh my gosh, look. They gave us something we don't have to change a thing. I love it. So let's go ahead and add. Oh man, cancels out, cancels out. Everything cancels out. You got nothing left. 0 is your number. That represents nothing. And then here though, -8 plus 7, that's -1. Okay, when our x's and y's are gone, we just have a statement and we have to look at it. Is this statement true? Does 0 equal -1? No. And when you hear yourself saying no, that means no solutions. Okay? All right, let's see what this last one is. All right, here, thank goodness, there is a no. We don't have to make a wish or anything. We just have to add. So -2x plus x, that's -1x. Or I could have just put -x. I don't know why I did that. These cancel out. -1 plus 3, that's going to be 2. And I'm going to divide both sides by -1. Guess what? I know why I did this one. Okay, when we get an answer, we can stop here. We got an answer for x. It doesn't ask us. It doesn't ask us to put, it just asks us to pick one of these, right? So if your x is still there, or let's say we solve for y and your y is still there, we get an answer for x or y, that means it's one solution. You don't have to keep going to find y. You know it's one solution. So once again, the new thing was, if your x's and y's go away and you end up with a statement, right? It's either going to be a true statement or not. We say, is this a true statement? No, it's no solution. Here, all x's and y's went away, but our statement was true, which means infinitely many solutions. There's an infinite amount of points that are on both of these lines that work out, right? That's what it means, infinitely many solutions. And then when you solve and you get an answer, that means that there's one solution. All right. Fun, fun, fun. Please, please, please ask me questions in class. Thanks for joining me.